Hello, everyone, and welcome back to IGCSE Chemistry by MindLab Diaries. So, in today's video, we're going to take a quick look at electrolysis. After a look at what it is, generally, we'll see how we can use it to separate the elements in insoluble ionic compounds like lead bromide. Equipment. Before we see how it works, though, you need to be familiar with the equipment we use, as you could be asked to draw or label it in the exam. First, we need some kind of beaker in which we place our electrolyte. An electrolyte is just a liquid or solution that contains an ionic compound, with the important point being that the ions in the electrolyte are free to move. If our compound was soluble like copper sulfate, then we just dissolve it in water, and that aqueous copper sulfate would be our electrolyte. However, if it was insoluble like lead bromide, then we'd have to melt it to get a molten liquid, because that's the only way to make sure our ions would all be free to move around, because they are the charge carriers in an electrolyte. So if we change our electrolyte to be molten lead bromide, then it would contain positive lead ions and negative bromide ions, both of which would be free to move around. Next, we need our electrodes, which are solid conductors generally made of metal or carbon. On the right, we have the positive electrode called the anode, and on the left, we have the negative electrode called the cathode. Lastly, we need to join the electrodes with some wire so the electrons can flow between them and add some kind of power supply like a battery to drive that flow of electrons. Electrolysis. The word electrolysis literally means splitting up with electricity, and that's exactly what it does. By using our battery to pass an electric current through the electrolyte, which in our case is molten lead bromide, we can separate out the lead and the bromine. The way this works is that the negative bromide ions will be attracted to the positive anode, and when they get there, they will be discharged, which means that they go from a charged ion to a neutral atom. In bromine's case, this will cause the atoms to pair up and form bromine gas, which can then float off. Meanwhile, the positive lead ions will be attracted to the negative cathode and again be discharged, this time to form pure lead, which will then fall to the bottom and form a layer of molten lead. Oxidizing and reducing. So, the last thing to point out is that the ions are actually being oxidized and reduced at the electrodes. In our example, at the anode, the bromide ions are being oxidized to bromine and lose one electron each in the process, which is written as a half equation. Meanwhile, at the cathode, the lead ions are each being combined with two electrons and being reduced to form pure lead. So, what's really happening overall is that the electrons from the bromide ions are being passed to the positive anode and then transported along the wire to the cathode using the power of the battery. These electrons are then given to the lead ion, turning it into pure natural lead. So, we're using electricity to convert the ions in a compound back into their pure elemental forms by transferring the electrons from the negative ions to the positive ions. In the next two videos, we may look at the electrolysis of metal oxides to extract pure metals and the electrolysis of aqueous solutions. That's all for this video. If you enjoyed it, please let your friends know about us, and we'll see you again next time. Thank you.